everyone, and welcome to Interactive Stargazing. My name is Victoria, and I'm one of the public program educators at Lowell Observatory. And tonight we're going to start off with the 37 cluster, which you can see here. This is an open cluster of stars. So these are all relatively young stars that formed somewhat recently and are now in the process of spreading apart from each other. They're all moving away from each other and spreading out across our galaxy as each star finds its own happy orbit around the center of our galaxy. And these stars just happen to be shaped like the number 37. And somewhat luckily tonight, it's oriented so that you can actually see the 37 the way we'd normally write 37. Oftentimes when we're looking through telescopes, it ends up upside down or backwards, something like that. So yeah, it's kind of nice to be able to see the 37 as a 37. We can head on to our next object, which is not to be confused with this one. Our next object is M37, which stands for Messier. This is another open cluster of stars. So these are, again, stars that all form together and are now moving away from each other as they spread out across our galaxy. The difference is this one was cataloged as part of Charles Messier's catalog of non-comets. Messier was an astronomer in the 1700s who really wanted to find comets. He was very interested in finding comets because that was how he made money. He would name them after French nobility. And so he wanted to find comets. But everywhere he looked in the sky, he could see these fuzzy things that he thought were comets, but when he went back a week later, so they were in the exact same spot. So it couldn't be a comet. And this is the 37th list or item in Charles Messier's list of things that were not comets and therefore boring to him. However, the list is full of things that are really quite pretty, like this open cluster of stars. So these stars, again, all form together and are now moving away from each other as they spread out. This is not to be confused with a globular star cluster, which our next object we can head to, and that's going to be M2. So another of Messier's objects in his list, but globular star clusters are a little bit different than open star clusters because they're gravitationally bound. So here all the stars are spread out and they're pretty far away from each other. None of the stars are compact, whereas here we can start to see these stars are more compact. They're all jam-packed right next to each other. They're very, very close. Typically, these clusters have hundreds of thousands of stars. This one has probably around 150,000 stars in it. But they're very tightly packed in a very close radius. This one is 175 light years in diameter. For a bit of context, the closest star to us is 4 light years away. So if we were in one of these globular star clusters, we would see stars all over the sky, very bright ones too. But it's actually pretty lucky we're not in a globular star cluster because the stars are so close. The gravitational forces are very intense, and you would have gravity from other stars, and that tends to tear planets off of stars. And so there generally aren't planets around these kinds of stars in globular star clusters. They're also some of the prettiest objects to look at, in my opinion. I think that they're some of the most spectacular objects that we're able to see, whether through things like this or actually looking through an eyepiece. Either way, they're stunning. They look like someone spilled glitter on velvet or spilled salt on a tablecloth. Either way, they're some of my favorites. Looks like we've got a request. We'd like to know about Stefan's quintet and what it looks like tonight. I'm not sure if our system will have that, so we may need to look up something else for it. Sometimes our program doesn't have all of the catalogs, so we have to look up others, but it looks like we've got this one. And I've never actually looked at this object, so we'll see what it is. I kind of like this. It's like a guessing game almost. For stars. I am not quite sure what this is. It could be a cluster of galaxies, possibly, but I am not entirely sure. Yep, it definitely looks like some galaxies. And I think with a little bit longer exposure, we could, there we go. Yeah, we can definitely see that these are a bunch of galaxies. That's awesome. Okay, so these are galaxies that are probably pretty close to each other, like us and the Andromeda Galaxy and the Triangulum Galaxy are all close to each other. These galaxies are like that. So, yeah, you can see some of the fuzziness of these galaxies, and that comes from the fact that this is like hundreds of millions of stars at least, probably more than that, that are all kind of fuzzing together, and they're all blurring because there's so many stars. So we're seeing the diffuse light from all of those stars, which is just mind-boggling if you think about it. When you look at this image, you might say, okay, there's a handful of stars here, but really there's hundreds of millions of them, because each galaxy has hundreds of millions of stars in it. And so we've got a whole bunch of these different galaxies that are all clustered together. And so I think it's always really neat to see multiple galaxies all at once, because it's just mind-boggling to think about the number of stars, and then from that you can go on the number of planets, because each star probably has a planet around it. And so if you think about our solar system as being pretty typical, we've got 8 planets, a couple hundred moons or so, lots and lots of other things like asteroids and dwarf planets. So there's probably, an uncountable number of places to set foot on around those stars as well. We've also got a request for the Stingray Nebula, but unfortunately the Stingray is in the southern hemisphere, and we are located in the northern hemisphere, so we're not able to see that tonight. But that is a planetary nebula, so we could try something like the Blue Snowball. The Blue Snowball is another planetary nebula. We are heading there now. Planetary nebula are the ends of the life of the star. And so as stars age, they expand. They start to lose pressure, and they expand, and they kind of bubble out. And the blue snowball is kind of the next step. After a star ages and it starts to expand, small stars just keep expanding, and they keep bubbling out and expanding and expanding and expanding until they're this diffuse bubble of gas. And that is what a planetary nebula is. It's the gas left over from a planet, from a star that it died and kind of fizzled out. Most stars will fizzle out. They won't go boom like a supernova, but instead they'll just kind of fizzle out and leave behind these little bubbles of gas like the blue snowball here. Now we're going to take a trip back in time. We've got a request to see the Orion Nebula. So kind of piecing together a star's life in different pieces. So the Orion Nebula is a stellar nursery, and it's where baby stars are born. So it's where lots and lots of stars, oh, there it is. It's where lots and lots of stars are being made. In fact, the Orion Nebula is one of the most productive stellar nurseries nearby us. So it has the potential to have over 1,000 new stars be born from this big cloud of gas and dust. And what happens here is the gas collects and it combines with itself. So little molecules attach to each other. And then you kind of just add more and more onto it over and over again until eventually you get a big ball of gas. Once something reaches a certain mass, once it gets big enough, it'll naturally form into a ball, which is the most gravitationally stable shape. So it will form into a ball. Then that ball will start to perform fusion. So it takes two tiny hydrogen atoms and smashes them together in its core. That's the process called thermonuclear fusion, and that's how stars are kind of defined. Stars are things that perform fusion. So stars perform fusion, and once these young baby stars start to perform fusion, they're stars. And so they start giving off light and lighting up the gas around it, which is actually why we can see the Orion Nebula in the first place. Is because all of those stars that are lighting up the gas around them. And so that bright light in the middle comes from a popular or well-known combination of stars called trapezium, which there are 4 to 6 that you can typically see with a telescope in that little center part of the nebula. And there's the 4. And this is a really great example of how exposure times can change what we see. So right now we're at a very low exposure time, so we're not taking in a whole lot of light. But as we increase that exposure time again, we'll see more of the diffuse gas around it, which is harder to pick up because it's dim. It's just being lit up by the stars. It's not the stars themselves. And there's that bright nebula again. The pink here tells us that there's hydrogen here, and hydrogen is the building blocks of stars. I mentioned that stars perform fusion, and they smash that hydrogen together to perform that fusion process. So hydrogen is essential for stars, and the Orion Nebula is chock full of it. So there's a whole lot of hydrogen in the Orion Nebula to make lots and lots of baby stars. Let's go our next object to M33. This next object is another galaxy close by us called the Pinwheel Galaxy or the Triangulum Galaxy. Now, it's called the Triangulum Galaxy, and you might have picked this up as our operators were moving around the telescope, but it's right next to a constellation called Triangulum, which is 3 stars in the shape of a triangle. It's one of my favorite constellations because it's so simple. There it is. There's Triangulum, and the Triangulum Galaxy is right next to it. This is one of the closest galaxies to us. You can see it has those big spiral arms full of stars and gas and dust. But the Triangulum Galaxy is second only to the Andromeda Galaxy in proximity to us. It's the second closest galaxy, which is one reason why we can see it in so much detail. Here we're even picking up some of those dust lanes in the galaxy as well, and those big spiral arms that swoop out that are full of stars and gas and dust. Now the Triangulum Galaxy is under the best conditions, so beautiful night sky, no moon, no city lights, no clouds, perfect eyesight. Under all those conditions, you can see it naked eye, according to some people. I've never been able to see it naked eye, but there could be a lot of reasons for that, including the fact that I wear glasses. Who knows? Yeah, you might be able to see the Triangulum galaxy if it's very, 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 very dark. You would need a real dark sky sight to be able to see the Triangulum galaxy. It's also comprised of about 40 billion stars. So as we're looking here, you might say, oh, there's like 100 stars in the spring. No, there's much, much more than that. Up to about 40 billion is our estimate for this galaxy, which is a relatively small galaxy compared to ones like the Milky Way and the Andromeda galaxy. The Milky Way has up to about 400 billion stars, and the Andromeda galaxy has up to 1 trillion. These are all depending on estimates, so it's not like someone is sitting there counting all the stars, of course. Speaking of the Andromeda galaxy, let's head there next. And the Andromeda galaxy, of course, also has an M number associated with it, so it's one of Messier's non-comets, an object that he spied in the sky night after night and got tired of thinking, oh, is it a new comet? Nope, it's just the Andromeda galaxy again. And the Andromeda galaxy is so much closer to us that it actually takes up about 4 full moons in the sky. So you can't see all of that, and our telescope doesn't have that wide field of view. But, oh wow, this is phenomenal. Okay, but you can see at least the core of the galaxy, so that's that bright spot in the center, and then around it, at least with a photographic system like we have, you can start to see those dust lanes. And so here you can see an incredible amount of detail on those edges, those spiral arms. And I think, again, this is one of the most spectacular things that you can see in the sky. The Andromeda galaxy is also visible naked eye. So if you have dark skies available to you, especially on a night like tonight, where hopefully it's not too cloudy where you are, in Flagstaff it's not all that cloudy either. Hopefully you have good conditions and you can hop outside and take a look. The Andromeda galaxy will be pretty much straight up. It'll be a little tiny fuzz ball that you might see out of the corner of your eye. And it's incredible that we're able to see it naked eye. In fact, we swoop over to the constellation view, you can see in the constellation Andromeda kind of where it's located. So there's Andromeda, and there's the Andromeda galaxy. But the Andromeda galaxy is also hurtling towards us. The Andromeda galaxy is our next closest neighbor, and it just keeps getting closer. In fact, the Andromeda galaxy will collide with the Milky Way in about 4 billion years. But the incredible thing is that the Andromeda galaxy is, and us, we're not going to do all that much when we collide. In fact, the odds of 2 stars colliding with each other is pretty much 0, because there's so much empty space in space that there's not a whole lot of odds or likelihood that 2 things will collide. And it looks like we've got a request for M33, which we just did, so I'm more than happy to go back to M33. Or we can go to Mars. Unfortunately, Jupiter and Saturn did set earlier, but we will be hosting a special live stream event for their conjunction on December 31st, and that will be at 5 p.m. Arizona time. So you will be able to see Jupiter and Saturn, weather permitting. But in the meantime, here is Mars. Mars is awfully bright, but as we lower our exposure time, we can see a little bit of surface detail on Mars. And yeah, there we go. So we can start to see some of those old volcanic fields on Mars. Mars is a planet that's full of volcanoes, similar to the Earth, but it has the biggest volcano. In fact, the biggest mountain in our solar system, Olympus Mons, is a big volcano on Mars. There's cute little Mars. You can see that there's almost like a little bite has been taken out of it. And that's because Mars doesn't go through phases quite like the moon or Venus does. But it still has times where the sun isn't shining perfectly on it, so we don't see its whole entire face. Instead, we just see like a little tiny chunk missing from it, and that's due to the way the sunlight hits it. We've got a request for M74. This is another galaxy. And I don't think I've ever looked at M74 before. Wait. So we're typically taking exposures of a couple seconds or so. We like to take a long enough exposure to where we start to see detail, but not so long that we all have to wait forever to actually see the image pop up. But there, it looks like, is M74. And we can see it also has those nice spiral arms that are pretty typical of a galaxy. Most galaxies are spiral in structure. They have these big spiral arms that either go out from the center or from a bar that crosses through the middle of the galaxy. And they swirl out around it, much like you see here. And again, we're probably looking at hundreds of millions or billions of stars. And I think that's pretty incredible. And then we've got a question. What does Epsilon Lyra look like in the scope? Well, we can certainly take a look at that and not just tell you what it looks like, but show you. So Lyra is that little constellation that the mouse is hovering over. It's supposed to be in the shape of a heart. But here we have Epsilon Lyra, which I believe is a double star, but I'm not sure if we'll be able to resolve it or not through the telescope. So there's some things that matter with a telescope, and one of them is resolving power. So you can think of resolving power like when a car is driving towards you on the highway at night, and you see, when it's far away, you can see it as just like one blob of light, but as it gets closer and closer, you see, okay, there's two headlights. It's on a motorcycle. Yeah, so telescopes also have that, and like how much can you separate two things from each other? And so here we can see that these are two different stars. And the cool thing about this one that I've now remembered is that each of these stars is also a double star. So not only do these two stars appear to go around each other, we've also got each star is two other stars that go around each other. So this one is often called the double-double. And it's just a whole bunch of stars, which are really, really neat. We've got a request for Neptune next. And I believe Neptune is in the sky tonight. And we should be able to take a picture of it. And off the telescope goes. This 14-inch CDK planewave telescope that we're using is one of my favorites, and part of the reason is because it does move so fast. We're able to see a whole lot of things and move it very, very quickly. The telescope itself moves very fast because it's pretty light. There's not a whole lot of meat to it, and so it moves very quickly. And there's little Neptune. Neptune is actually the first discovered planet, the first mathematically discovered planet behind Uranus. So after Uranus was discovered by William Herschel, it really threw a wrench in our solar system. Suddenly, the math that was working out, like Newton's laws of gravity and Kepler's laws of planetary motion, they don't work as well with Neptune, the astronomers found. And so, either we had to invent a whole new system of physics or fix Neptune somehow. And so it was later discovered that part of that came from our estimation of Neptune's mass. We originally estimated it about 5% too small, I believe. And so that was throwing everything off. But we also forgot to account for the moons of Neptune. However, the search for another planet beyond Neptune that caused it to speed up in parts of its orbit where it shouldn't eventually led us to discover Pluto, which we cannot see tonight, unfortunately. We can see Neptune, and possibly a moon, I'm not sure. That's a moon nearby it. All right, we've got one more request, and then we'll finish things out. So we can see one of Neptune's moons, it looks like. So our next request is NGC 253, and this will be our last request for the evening. We're looking at the Sculptor Galaxy. Lots of galaxies tonight. That's the nice thing about not having the moon. Unfortunately, the moon isn't up tonight, so we can't look at the moon, but we can look at a whole bunch of other things, including these galaxies, which are generally very, very dim and very difficult to see. So on a moony night, it's more difficult to pick out these galaxies from the background sky. But there is the Sculptor Galaxy. And we can start to see that center of the galaxy where there might be a supermassive black hole. And then this one is kind of tilted towards the side towards us. So it's more difficult to make out the spiral arms, but you can see some of the spiral structure in there. This is a really lovely galaxy. And again, my favorite thing about galaxies is that when we see them, we're looking at hundreds of millions, if not billions of stars all at once. And all that starlight is hitting your eye, and it's traveled millions and millions of light years just to hit your eyeball. In this case, it's a little bit more complicated than that because it goes through a whole bunch of computer screens before it hits your eyeball, but same concept. Now, our final object for the evening, let's head on over to the Crab Nebula. This is M1, so it's the first object in Messier's list that he decided to write down. Again, Charles Messier was an astronomer who was looking for comets, and so he thought this little fuzzball looked an awful lot like a comet. Through a telescope, it does just look a little bit fuzzy. So he thought that, hey, maybe it's a comet, but no, it's just the Crab Nebula. It's just the remnant of a supernova. So earlier we talked about planetary nebula and how it's the death of a star as a star expands and kind of sheds off its outer layers. This is the more explosive and more exciting death of a star. A supernova is what happens when that star expands and expands and expands and then becomes unstable. This only happens with very, very, very large stars. And so the star expands and explodes. and it leaves behind a more intricate pattern of gas and dust left behind, which is what we're looking at now. And so this supernova was actually observed by astronomers about 1,000 years ago, mostly Chinese astronomers, who looked up at the night sky and they saw this bright point of light suddenly appear for a couple months and then disappeared. So that is about all we have time for this evening, before my telescope operators freeze to death up there. But before we let you go, I did want to mention one last thing, is that we do offer our premium access up at our Giovanni Open Deck Observatory, where you could, on another night of the week, be able to experience these telescopes for yourself. We are also offering programs for the Jupiter and Saturn conjunction as well. These are all available for booking on our website, lowell.edu. So thank you all, and have a wonderful rest of your evening.